Hello students, this is the topic we are going to take up in this video presentation is preparation of phosphorus halides, their chemical properties, particularly hydrolysis and their uses. So let us start with a very good thought, focus on the good. So you may be facing your good and bad things in your life, but you should concentrate on your good. Slowly that bad thing will be off from your side. So learning outcome from this session is, so you will be able to explain about phosphorus halides, that is PCl3 and PCl5, properties, their preparation, reactions of phosphorus halides and uses. So let us discuss first of all PCl3 and PCl5 are two phosphorus halides where phosphorus, the hybridization is sp3. How to calculate? We are already aware of that inorganic chemistry basic fundamentals. We have discussed their hybridization methodologies. Z is equal to half. Z we have to calculate. Z means the number of hybrid orbitals. 1 by 2, valence electron 5, monovalent 3, 5 plus 3, 8. 8 by 2, 4. 4 means sp3. Similarly, Z is equal to 1 by 2. 5 is the valence electron plus number of monovalent 5, 5 plus 5, 10, half of that 5 sp3d. So this way we are able to calculate the hybridization. Along with that, geometry is tetrahedral but shape is pyramidal due to presence of one lone pair. Okay, and pentagonal because 5 bond pairs are there, no lone pair is there, therefore geometry is and shape is same. So now next thing is hybridization. If explanation we have to do. So C phosphorus is having the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p3 and 3d orbitals are empty. So now one electron will jump from 3s to 3d, so making 5 orbitals, 1 from 3s, 3 from 3p and 1 from 3d. They are mutually intermixing with each other to form hybrid orbitals. That hybridization is known as sp3d, and that 5 sp3d orbitals overlap with the chlorine to form the sigma bond. Okay, so this way we are able to calculate about the hybridization and explain about the hybridization. Similarly, if you take phosphorus penta fluoride, that is also be the same. And you see here very important thing is there are 5 different angles. 3 are in one plane and 90 degree above the plane, 90 degree below the plane. And so this above the plane and below the plane, that are known as axial bonds, and this is known as equatorial bond. PCl3, 3 equatorial bonds are there and 1 is axial bond is there. So always question can be asked is why axial bonds are longer as compared to the equatorial. So now you should see that this, if I am considering this bond length PCl, this is one bond pair, and this bond pair is repelled by this bond pair, this bond pair and this bond pair and this one. Means from the plane as well as opposite axis also. So this undergo the repulsions in the axis. Same is the case for this axial bond below the plane. Now but here PCl bond will be repelled by either PCl and PCl because of same. That will not be having much effect, because already the bond length is very large. Okay, so thereby elongation takes place. Okay, let us move to the next part, preparation. First thing is that PCl3 is colorless liquid, boiling point of 349 Kelvin with a pungent smell. And this is the geometry. You can see there 3 bond pair are there, 1 lone pair is there, pyramidal. And PCl3 prepared by heating phosphorus in the presence of dry chlorine. So reaction is there in front of you. And action of thionyl chloride. Thionyl chloride is SOCl2. Thio is related with the sulfur. Always remember that. And we are getting that phosphorus when reacted with thionyl chloride gives rise to PCl3 along with sulfur dioxide and S2Cl2. Next point is hydrolysis. So PCl3 on hydrolysis give rise to H3PO3 along with HCl. So means to say both acids are formed. Preparation of alkyl light from alcohol. This is important reaction in terms of organic chemistry. In this reaction we are converting acid to acid halides or alcohol to alkyl halides. So, and the byproduct is H3PO3. Okay. So now if you talk of PCl5, that is a colorless solid but impure sample, may be greenish yellow, sublimes at 373 Kelvin, and it can be produced in the similar manner P410Cl2. Here 10Cl means chlorine is in excess, so PCl5 is formed. Similarly, previously we have taken, if you remember, just see, we have taken here SOCl2, but in the next with PCl5 preparation we have not taken SOCl2, we have taken SO2Cl2. So please remember this, don't forget that all these things, there is a point of confusion. PCl5 plus sulfur dioxide will be formed. Okay. So now the next point is hydrolysis. Same way, if you see earlier, PCl5 3 hydrolysis gives H3PO3 as well as acid, but here if partial hydrolysis is there, POCl3 and HCl will be formed. If total hydrolysis is there, H3PO4. Please do remember that PCl3 H3PO3 was there, and in case of PCl5 H3PO4 would be obtained. Similarly, thermal decomposition of PCl5, as you know, two bonds, axial bonds are not much strong. Why? Because the bond length is more. So bond length is more, it can break easily. So PCl5 will give PCl3 to and Cl2. Okay. Similarly, alkyl halide we can prepare from alcohol by this reaction. Ethyl alcohol PCl5 gives rise to ethyl chloride plus POCl3 HCl. These are very important reaction in alkyl halide organic chemistry. Now let us talk of the uses. So the same thing we are discussing here. We have converted just now carboxylic acid to acid chloride. So CH3COH plus PCl5 gives rise to CH3COCl plus POCl3 HCl. And alcohol C2H5OH plus PCl5 gives rise to CH3CH2Cl, POCl3 and HCl, and PCl5 extensively used as chloride is same, only everything is same, only difference is with the byproducts. H3PO3 is formed in case of PCl3, and 3 moles we have to take for acid as well as alcohol. But in another case PCl5 the products are the same, but byproduct is POCl3 and HCl, and there is no 3 moles we have to take, only 1 mole. So let us take up this question. On reaction with chlorine, phosphorus form 2 halides. So you must have understood that 2 halides will be PCl3 and PCl5. A is yellowish and white powder. So powder, you should know that it would be the powder, whether PCl3 or PCl5. And B is colorless oily liquid. Identify and B, write the formula for the hydrolysis. You have to talk of hydrolysis. You know that PCl3 hydrolysis gives rise to H3PO3 and PCl5 hydrolysis gives rise to H3PO4. Hopefully you have solved in the right manner. So this is the answer. PCl5 gives H3PO4 and PCl3 gives rise to H3PO3. Okay. Yellow is PCl5, oily liquid is PCl3. So next is the same thing here, the reactions, and let us have the summarization for what we have done. Phosphorus forms 2 trivalent halides and pentavalent halides. Hydrolysis, PCl3 gives H3PO3 and H3PO4. PCl3 is sp3 hybridized. PCl5 phosphorus is sp3 hybridized. PCl3 is colorless liquid while PCl5 is a solid. Both are having pungent smell. Both PCl3 and PCl5 are used in organic chemistry for preparation of alkyl halides as well as acid halides. So let us see this question. The question can be asked in this manner: why all PCl5 bonds are not equivalent? So you can say that because axial bonds are repelled by 3 bond pair in the plane and 1 at axis. Therefore, the bond length is elongated. On the other hand, equatorial bonds are repelled by 2 equatorial bonds, hence they have least repulsions. And moreover, we can explain the structure also: triangular bipolar structure and 3 equatorial plane and 2 axial bonds are there. So this way we can, therefore this decomposition also takes place. This is the reason. And the next is PCl3 fumes in air. The answer is because on reaction of water we are getting H3PO3 and HCl. HCl is producing that fumes. And PCl5 acts as oxidizing agent as well as reducing agent. Please to understand that a substance will undergo oxidizing agent or reducing agent depending upon whether it will lose electron or gain electron. A substance which lose electron will undergo oxidation and act as reducing agent. As substance, now PCl5 phosphorus is in maximum oxidation state of +5. It cannot lose electron. So it can gain electron only. So if it gains electron only, then what will happen? Reduction takes place and it will act as oxidizing agent only, not reducing agent. So this is the concept if you understood. then writing the answers are very easy. Okay, so it can decrease the oxidation state but not increase. Okay, if it's not increasing, so there is no point of reducing agent, it will act only oxidizing agent. So hopefully you must have solved all the questions properly and may be aware of that. So congratulations to you for that. So again, the thought is focus on the good. Thank you.